Professor Vic Brokaw, Professor 42 here, bringing you the second lecture in the art of debugging. Before we can tackle nasty debugging situations, we need to become familiar with the debugger and its various features. So for today, I've picked a relatively easy, incorrect output problem to try to solve with our debugger so we can get familiar with how the debugger itself works. The program itself is going to produce a report of the policies in force based on state code and agent number. To start with, let's look at what the raw data looks like. The raw data contains the person's policy number down the far left column, and then comes the state code. Illinois, for example, might be state 13 very often. And notice that they are all in state code order. All the state 1s are first and then the state 2s. The third column represents the numerical ID number of the agents selling the policies in that state. And notice all the agent 1's data are together, followed by all the agent 2 data in state number 1. Then when we go to state number 2, they've numbered their agents with the same numbers, doesn't matter, but they're all in the same order. All of the 1s are first and then all the 2s. The rightmost column, of course, is the premium on that particular policy. What are we trying to produce? Here's the report we're trying to produce. The policies sold by state and then by agents. And notice then we've got for state 1, agent 1, here's all of his policies. When we get to a different agent or a different state, we stop, produce the total policies that this agent has sold, the total amount of premiums he's collected, and then we go to a new page and start the next agent in that state on a new page. Now, for those of you who are wondering what that funny little symbol is, when you send a form feed to the printer, it causes the printer to do a page eject. When you look at that same report under Notepad, it comes out with this little funny character that represents the form feed code. Anyway, continuing on, here will be the results for state 1 and the second agent in the state. Now, when the state changes, we stop and print out the totals for the current agent we were working on when the state number changed, and then we print out the total policies that are in force for that particular state and the grand total amount of money in that state. And then we kick off to a new page with the new state and the first agent in that state, and so on down the line. That's what we're supposed to be producing. That's our actual report. All right. I put in a few bugs, and the bugs are relatively easy for us to find because today we're focusing on how do we use this debugger. First thing you notice, if you just say start without debugging, program runs. In this case, the output was sent to a report file and we don't see anything in our DOS window. So one tip, when you've got a situation like that, you can add the existing report that you're producing that doesn't appear on the screen to the project. So here I've right-clicked, chose add existing item, and I'll scroll down and pick the output, which was the policy report.txt file. Now I've added it. The nice thing about it is if I double-click it over here, there's our report showing up on the screen. And we can look it over to see if it's working properly the way it's supposed to. And in this case, we see potentially some boo-boos. First thing we see, of course, is the page numbers are always page number 1. And we should probably compare it to the output from the other working program so we can get an idea of our boo-boos. And in this case, I'll add the existing item for the good one here to our project so we can compare the two. So it looks like we've got 3 policies for the agent, 1049, and then we go to the next agent, 3 policies and 1135, and in our case we're getting wrong numbers for the total premiums. And for the state totals, everything is zeros. So we've got some boo-boos in the state tallies. We've got some boo-boos in the agent tallies. We'll try to figure out what these boo-boos are, but we'll do it by using our debugger. So the first thing to notice is that you can't just come up here and choose Start Without Debugging and expect it to find your errors. The first thing we need to know about our debugger is that it will allow us to set any number of what are called breakpoints. A breakpoint is a spot in the program which, when an execution gets up to that instruction, it will stop and allow you to examine things and do various sundry things. How do you set a breakpoint? You simply go in the margin, on the left margin in the gray area, and click, and it puts in a red dot. The red dot indicates the breakpoint. To get rid of the breakpoint there, click it again. To put it back, click again. It's as easy as that. So let's start and put in one simple breakpoint and see what happens. Now, in total generality, what I usually do when I'm looking at a program is at least scroll down to the return 0 back to DOS and stick a breakpoint there. Now, all else fails, you'll stop it before it gets to the very end. But for today, let's just put one at the very beginning so we can get familiar with our debugger. I put it right where we start initialization phases. And then I'll hit Start Debugging. And boom, we run until it gets to this spot, and it stops at this particular spot. Now at this point, I want you to notice several key features about the debugger. Down here in this bottom window on the Autos tab, what this is showing you are the automatic storage variables in the vicinity of where you are paused at. In this case, we've defined a bunch of variables and are about to initialize them. So he's showing us the current contents over here in the value field of these various variables around the spot where we're at. And in this case, notice the variables are all core junk, garbage, because we haven't really started setting them equal to anything. The next tab over is sometimes even more useful. It's called locals. Here it shows you all of the local variables for the function that you're currently in. We're in main, so it's going to show us the contents of every local or automatic storage variable in main, including things like the input file and the output file, that sort of thing. Here they all are. Notice there's a slug of them. It's every one of them, and we have to actually scroll to see the current contents of them all. So the locals always shows you everything that's automatic storage in the function. Autos shows you the ones that are around where you're at execution wise. There is another one that's important for us. It's called the watch window. Right now my watch window is empty, and we'll put some stuff in there in a bit when we get to it. Now let's look at the next feature of the debugger. Back up on the Debug Menu tab now, we've got a number of different things. Of course, we could stop debugging, and you'll want to do that if you find a bug and fix it and want to start over. You'll stop debugging and then start again, recompiling and such. But the two I want to point out are step into and step over. What step over does, and the difference between that and step into, has to do with functions. If you are positioned on a function call, you're about ready to call a function, if you hit F10, step over, then the compiler will go ahead and call the function, carry out all the instructions in the function until it comes back to the point of where it was called. In other words, you're stepping over the function. You're not going into all the instructions. He'll simply execute them and then come back and show you the results. Step into, F11, on the other hand, if you hit that, it will then step into the first instruction inside the function, and you can carry on executing step by step through the function to see what's going on. Sometimes my students get clever and would like to step into the insertion and extraction operators to see what's going on. And of course, when you get into those kind of function calls, the code goes on forever. And they'll hit F10, 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 and they'll finally give up because there's thousands of instructions to input and output data. There's a useful one, step out. If you find yourself accidentally stepping into a function that's going on forever and you want to get out of it, don't just stop the whole debug run. Simply use the step out menu item or shift F11. for today, the two that we are really after will be step over or step into. All right, let's just see what that does. We'll do an F10 here. We're ready to execute, setting the total policies for agent to 0, and I'll do an F10. And notice the little arrow has moved, yellow arrow has moved down one line, showing us he's executed that instruction. We can verify it over in our automatic storage window or the locals window, and notice total policies for the agent is now 0. And notice another key feature of the debugger. When a value changes, he highlights that change to value in a different color, red here in this case. I'll do another one, another F10. And now notice he's set the total premiums to 0, and he's highlighted that one in red. If we look back at our locals, which contains all of the automatic storage variables, not just the ones around where we're currently executing, notice our two values that we've just set are highlighted in red for us. It makes no difference which one of the two windows you want to look at. Now in our case, the first glitch was this business of the line count number being off. So the line, let's look at what's going on here. We've got a function called headings. The headings is going to take the output file report to display the headings on, and a line count, and the state code to display in the headings, and the agent number to display in the headings. So the headings is the first area we've got a glitch. Notice it's called twice, once at the start and once at the bottom. Well, we know from the previous output that it was getting page 1 on the first page. It was page 2 that stayed at page 1. So let's go and stick a breakpoint down here at the second function call to headings and turn it loose. Here's the next nice trick. We don't have to F10 one line at a time. We can tell it to, again, continue, F5. Just tell it to go debug, and it will then run until a massive error happens and the whole program stops, a crash and burn type of error, or it reaches another breakpoint. In this case, we know it will reach that call to headings. So, boom. All right, we'll reload it. It's the report file over here. Let me close that one. We are now down here ready to call headings. At this point, well, the page number was 1 from our situation up there, our first function call. So now it's supposed to go to number 2. In this case, I'm going to choose step into F11. Let's go see what's going on in our headings functions. Sure enough, there's our page number. I'll F10 a couple of lines, and as you can see, our page number is 1 again. How strange. Let's set a breakpoint here and tell it to go debug, continue, continue, continue until you come back here again. All right, it's done that. It's gone and produced all the reports, and when there's a change and we need the headings again, it's back here again. It was that fast. And notice page number is 1 again. How strange. Let's run that again. Continue, do it again. And we go look at our output, and it's always page 1. So what's wrong here? Well, it's the page number. If you remember how local or automatic storage variables operate, every time it comes into the function, it creates storage for the automatic variables and initializes them. So every time we call headings, it's setting page number to 0 and then incrementing it to 1. What's missing here is the attribute for the different storage class, static. We'll stick in here static int page number. And now let's see what happens when we put that fix in. I'll delete that one, tell it to go, continue till we get to here. And yes, the polish report is out of date. We'll reload it. And at this point, page number is 1. I'll do another go till it gets to the next time through, and it's now page number 2. Yay! It looks like that is working fine. I'll remove the breakpoint and tell it to continue. It'll run until we program ends. Boink. Policy report has been modified. Yes, let's reload it and go look at it. And yes, indeed, 1, 2, 3, 4, we're in business. The page number error has been fixed. Now, the next thing that was wrong with our policy number was that we were getting goofy totals for all the states down here. So let's investigate that one. We have a function called doStateBreak and a function called doAgentBreak. If I scroll down to the two functions which are below headings, there's the agent break and here's the state break. Well, let's not look too much at the code and just say, well, let's go see what's going on in state break, and I'll stick a breakpoint down here at the point where we're going to output the incorrect results and turn the debugger loose, start debugging. It will run until we get to this spot. Again, I'll ignore this reload message for now. Now here we are, and again under the automatic storage fields, it is showing us the current contents it's about to output, which are 0. And I think at this point you can easily see the problem. I've certainly added the total policies enforced in the state to the grand company totals, but I set them back to 0 at this spot. So let's make that correction and return. So here I've moved the total policies initialization, total premiums for the state back to 0. I've moved those totals down here below the end of the output section. And we'll run it again. I'll rebuild it and run, and we'll take a look at what the output looks like this time. And if we look, we're getting correct counts for the total policies that are enforced in the state. Still got a glitch on the total premiums that are enforced for the state, and the company-wide numbers are bogus for the premiums, but certainly we fixed up one of the boo-boos in the accounting. So the next thing let's do is let's take a look and see if we can figure out what is going wrong here. And in this case, I'm going to set a breakpoint here in our agent break. That was the other break module, and turn it loose and see what we can have when we get to this spot. When we get to this spot, it has correctly added up the current agent policies into the state. It's added the current premiums into the state, and it's outputting the total policies for the agent and the total premiums for that agent, which is exactly what we want. Of course, then when we go to the next agent, we need to reset his policies and premiums for that new agent back to 0. And as you notice down here, I've set total policies for that agent to 0 twice. I forgot to set the total premiums for the agent back to 0. So we'll make this change. So now I've set both the policy number, the count of how many policies he's got and how much the premiums he's got. I got both of them set back to 0. And at this point I'll stop debugging and rebuild the program and start debugging again. Now when we get down here, we'll notice we're going to output the total policies for the agent, total premiums for the agent, and total policies. Let me make this a little wider down here. There's our total policies for the agent, the total premiums. They are looking good. And the total policies for the statewide, it should be the same. Looks good. I'll hit continue. And now notice it's changed. We've got 3 policies all right for the second agent, but his numbers are different. It's looking a lot better. When you think you might have it all fixed, you can remove the breakpoints and continue and allow the program to finish, reload the output report, and see how we're doing. Looking at a report, we have one final glitch. The total premiums for the state are coming out 0 consistently. And that rolls its way on up into the total company premiums. We still have some error left in our program. This time around, since the problem is this total premiums by the state, I'm going to copy that, and then when I hit the debugger, I'll set a breakpoint here. I'll run the debugger, start debugging, and when it gets to this point, I'm going to come over to the watch window. And in the watch window, I'll either type in total premiums by state or paste it in there. I'm going to choose to paste it in there. And it says there's the total premiums value for this particular state. And it looks like it's a correct number. But yet, well, let's do a continue and get there the next time. And notice its value is the correct one for the next time around. But yet, in the report, it's coming out zeros. Well, let's back up a tad. How did we get there? Well, we got there from this do state break up here. All right, let's continue and go till we hit that break point. Or doing our agent break again. I'll get rid of that break point and continue. And here we are, ready to call do state break. And the total premiums for the state is 0. That's not necessarily right. Let's do an F10. We'll step, I'll show you that one on the menu. I'm going to step over this function call, which means I'm going to allow it to execute and come back. All right, I called do state break. It should have taken the total policy, the total premiums that were collected and up to that point and added it in, and yet it's still 0. But we saw down here in our state that it wasn't 0, that it was the correct value, but yet it's still coming up 0. What's going on? Well, let's look at state break just a hair closer. If we look at the prototype for state break, are we passing them all by reference? We certainly are. Are we passing them all by reference in agent break where we actually roll the totals? Oops, no we didn't. We forgot a reference variable. So, when you change a function header, you've got to go back and get the prototype. If you don't, we'll have trouble. We'll come back and put it in both places. Now, this time I'll stop debugging and turn it loose, and we'll see that finally our program is indeed done and working correctly. We look at our output, Viola, we found the bugs. One other detail I'll show you for today. Let's go back into our headings module. First, let me delete all the breakpoints. Yes, and put one in our headings. One of the things you can do in your watch window when it comes up is in the watch window you can put in things like page number. And it will then show you what the page number is inside this particular function. Here is an alternative way to have found the fact that we forgot the static attribute to change the storage class from automatic to static. Page number is currently 1. I'll do a continue till we get to outputting the next page, and now the page number is correct at 2. If we take the static off, the page number would have remained at 1, and we could have spotted the fact that we've got the wrong storage class on this. We need page number to remember its previous value from the previous function call. So the takeaway from today's lesson is make use of your watch window. Notice the difference between locals and automatic. Automatic shows you the variable values around the line you're executing, but locals show you all of the automatic storage variables in the function you're in. Here I'm in headings, so there's just a few. They would also include the parameters such as line count and state code, as well as variables inside that function, page number, and so on. Alright, this gives you then a broad overview of our debugger, our tool we're going to use. We'll look at further features and obviously more complex debugging situations next time. Thank you.